Welcome to this explainer. Grab your notebooks, folks, because today we are diving into a full-on economics masterclass. We're going to look right past the dancing robots and viral internet clips to answer a very serious, multi-trillion-dollar question. Does the sudden explosion of humanoid robotics represent a genuine economic paradigm shift, or are we just looking at a classic tech bubble reminiscent of the dot-com era? I'm absolutely thrilled to be your guide for this lecture as we apply a strict, no-nonsense financial lens to all this humanoid hype. Here is the syllabus for today's lecture. We're going to cover the anatomy of humanoid hype, pricing the data gap, scaling physical world models, China's subsidized robotics race, proven industrial versus unproven consumer markets, and finally, human-robot labor economics. All right, let's kick things off with Section 1, the anatomy of humanoid hype, and that massive, multi-trillion-dollar bet.
We've seen insane, explosive interest right now from tech giants like OpenAI, Google, and Nvidia. They are all rushing in to commercialize what they firmly believe will be a multi-trillion-dollar market by 2050. I mean, when highly influential figures like Elon Musk suggest that Tesla's Optimus could bring in an unprecedented $30 trillion in annual revenue, wow. As economists, we got to take a step back. We have to ask ourselves, does this level of, frankly, mind-boggling hype actually build a viable, cost-effective supply chain? Or does it just artificially inflate valuations?
To really unpack this market, we first need to define the foundational tech driving these sky-high valuations. The industry's great hope is cracking the code of physical AI. Think of this as artificial intelligence taken completely off your computer screen and put into a literal physical body. Tech giants, notably Nvidia, are aggressively championing the physical AI chips and software needed to act as the brains for these complex networks of expensive sensors and actuators, which are basically the robot's artificial muscles. Moving right along to Section 2, pricing the data gap, which is a massive technical bottleneck. This brings us to a huge technical hurdle that directly impacts long-term capital valuations and investment risk. See, for a physical AI system to actually work, it needs to learn from experience. But as UC Berkeley's Ken Goldberg points out, we suffer from what's called the robot data gap. Unlike generative AI, which can just scrape an endless internet library of text, physical AI completely lacks the recorded three-dimensional physical experience it needs to learn. Nobody has captured the massive volume of physical motion data linked to camera inputs that these robots desperately need. The core economic issue holding back development here is actually pretty simple. Predicting the next string of words for a large language model like ChatGPT, well, that's relatively cheap because text data is literally everywhere. But predicting the exact forces and motor commands needed to fold your laundry without squishing the fabric, that requires incredibly scarce, difficult to capture 3D physical data. And that scarcity makes training these robots phenomenally expensive.
So how do we fix that? Let's get into Section 3, scaling physical world models and overcoming this gap.
With data being the absolute gold standard currency in this race right now, how are companies like 1X trying to solve this scarcity to justify their valuations? Well, there's a really stark contrast in training methods. On one hand, you have teleoperation, where humans wear VR glasses and literally puppet the robots around to generate real-world data. It's super effective, but man, it's slow and very expensive. On the flip side, you have world models. These are highly scalable, AI-generated synthetic virtual environments where robots can safely learn actions. The catch? Virtual worlds sometimes miss those messy, completely unpredictable details of real life.
So the ultimate goal is achieving what Professor Goldberg calls the flywheel. Think of this as a theoretical loop where robots finally get out of the lab and just continuously collect image and motion data while on the job. They use that hands-on experience to train a larger model, making the robots smarter, which then allows it to collect even better data. The first company to actually master this flywheel, they're very likely going to dominate the entire market. Now let's zoom out a bit for Section 4. China's subsidized robotics race, where geopolitics meets pricing. Shifting our economic lens from software training over to the global supply chain, we have to examine how government intervention is aggressively altering competitive pricing on the world stage. Get this, in 2025, the Chinese government pledged a staggering 1 trillion yuan. That is roughly 140 billion US dollars, earmarked as a strategic priority to advance emerging tech, with robotics right at the absolute forefront. It's a colossal injection of capital designed to help China dominate the humanoid industry, very much like the playbook they used for electric vehicles. And this kind of forced scale creates some fascinating market impacts. It's already spurred the creation of over 140 Chinese humanoid companies. Manufacturers like Agibot and Unitree are using deep vertical integration, meaning they make their own sensors, batteries, chips, the whole shebang, to just hammer down global pricing and achieve rapid manufacturing scale. Actually, this growth is so unnaturally fast that even officials over there are issuing warnings about a potential market bubble.
Which naturally leads us into Section 5, proven industrial versus unproven consumer and evaluating true market viability. As any student of economics knows, just because you can build components cheaply doesn't guarantee a commercially viable product. The contrast between these markets is wild. Traditional industrial robots have a highly proven return on investment. They do routine, fixed tasks like welding in very controlled factory environments. But consumer-focused humanoid startups, they are staring down massive investment risks. They're trying to build multi-purpose machines that have to navigate unpredictable, semi-structured spaces, like a messy living room or a chaotic hospital, where uncertainties are everywhere and the cost of an error could literally be life or death.
And we are absolutely seeing these growing pains play out in the real world right now. Early warehouse pilots run by massive companies like BMW and GXO Logistics show us that humanoids are, well, they're not quite ready to take over. Honestly, they're currently slower than humans, they have limited battery life, they lack complex dexterity, and, much to the dismay of warehouse managers everywhere, they drop or damage products pretty frequently. Right now, they still absolutely require constant human audits and supervision to ensure quality.
Let's bring it all home with Section 6, Human-Robot Labor Economics and the Long-Term Equation.
Let's look at the big picture here. There is a deeply urgent economic catalyst driving this entire industry forward, and it's demographics. It's estimated that nearly 2 million U.S. manufacturing jobs alone are going to go unfilled by the year 2033. That labor gap is widening fast, and humanoids are viewed by a lot of executives as the only truly scalable solution to fill that growing void.
But it's not all doom and gloom. We are already seeing glimpses of some really cool early collaborative successes. For example, GXO Logistics is deploying humanoids into extreme warehouse freezer environments. The humanoids go in and handle the freezing temperatures for a full battery cycle, completing tasks while their human teammates safely direct them from the outside. It's a fantastic way to protect workers from harsh, uncomfortable conditions.
Ultimately, as economists remind us, historical anxiety about machines taking our jobs is a tale as old as time. But the real variable for economic success isn't just about how cool the robot's hardware is, it's worker involvement. How intentionally we deploy these robots alongside actual human workers is what's going to dictate the true quality of work and our economic prosperity in the coming decades. And that brings us to the end of today's lecture. I'm going to leave you with a final exam question to chew on. Are we witnessing the dawn of a genuine labor revolution capable of delivering a multi-trillion-dollar return on investment? Or, weighed down by the data gap and fueled by artificial subsidies, are we just funding the most remarkably agile tech bubble in history? One destined to burst exactly like the dot-com era? The market is actively deciding the answer right now. Thank you so much for joining me for this explainer. Class dismissed.